Hi, this is Miss G. This is the first scenario in the weak/strong acid-base titrations classwork. So in this scenario, we've got 35 milliliters of 0.150 molar acetic acid, and we haven't yet titrated it with any sodium hydroxide. So this 0.0 right here that you see is the amount of sodium hydroxide that's been titrated, and that's nothing yet. So the only thing you have to do in this problem is figure out the pH of the acetic acid. This is just what we did in section 4C. So I'm going to write out the acetic acid, HC2, H3O2. When you put it into water, it dissociates into its conjugate base, C2H3O2 minus, and you produce some hydronium ions. So I'm going to write down the molarity of the original acid, 0.150 molar, and we know that that's going to lose some concentration when it dissociates. And we're going to gain some conjugate base, and we're going to gain some hydronium ions. So I'm going to stick these equilibrium conditions into the Ka for acetic acid, which is 1.8 times 10 to the negative fifth. And if I put that into the Ka expression, that's equal to x squared over the original concentration of the acid, 0.150 molar, minus x. And this x will be negligible, so I'm going to bring that to 0. So x squared, when I simplify this, will equal 2.70 times 10 to the negative 6. Then if I take the square root of both sides, I get x is equal to 0.00164,317. That's a molarity, and that in fact is the molarity of the hydronium ion. So that's the molarity of H3O+. So if I want the pH, I simply take negative the log of that molarity. So I'm going to take negative the log of 0.00164,317 molar, and that gives me a pH of 2.78, which is the answer. So again, this isn't anything new. This is just determining the pH of a weak acid. I'll write that at the top. pH of a weak acid. Again, we did that in section 4C. That's it. That's it for the first scenario. See the next video for the second scenario.